Guess what today is?
It's hump day.
Hump day!
That's right. Today is Wednesday, and here's the class opener. So on number 1, I'm asking you to divide the quadratic trinomial by the binomial x minus 5. Now you could do long division if you want, or you could do synthetic. I'm obviously going to go with the easier of the two, which is synthetic. So let me zoom in a bit here. And how do we do synthetic? I hope you remember, you put the opposite of what you see right here into the box. So that's actually going to be a positive 5 that we're putting into the box. And then you go through and you write down the coefficients of each term of your polynomial. So we have a 1 right here, a negative 1, and also a negative 20. Let me write that down. We have a 1, a negative 1, and a negative 20. Okay, so what do we do? I hope you remember, you bring down the 1, and then you simply take the 5 and multiply it by 1 and write the answer up here, which is going to give you a 5. Okay, and then what do we do? As you come down, you combine, and negative 1 plus 5 is 4. And then you take that 5 and multiply it by 4, and then you're going to get positive 20. And at the very end, we have the remainder, which in this case is 0. Okay, so when we divide the above quadratic trinomial by the binomial x minus 5, what do we get as an answer? Remember, the remainder is the number out here, which means that this one has to be the constant. That's just the regular 4, right? And which means that this next one has to be the x term. So you could put a 1x or just x plus 4. So in other words, the answer is, to the division problem, x squared minus 1x minus 20 divided by x minus 5, the answer is x plus 4. If you do the long division, if you actually worked it out with long division, and you had the x squared minus 1x minus 20, and over here you have the x minus 5, of course on your answer you're going to have an x plus 4 up here. Anyway, whichever way you did it, we got the answer x plus 4. Let's take a look at this next one. They're asking us to factor. That's really easy to do. What times what is the last number, negative 20, that if you add together is negative 1? Well, that will be x minus 5 times x plus 4. Okay? So why am I doing this? Because there's something that we need to understand here. If I divide and I get a remainder 0, then it actually is a factor. Okay, we'll get more into this in a little while, but right now let's think about this. I gave you a polynomial, we divided by a binomial, we got the remainder 0, which means that this was an actual factor. Now over here where we just factored, look, the x minus 5 is right there. It's actually a factor of the quadratic trinomial, right? Again, we'll get to that in a little while. I hope we're able to make that connection later. These notes right here, it says factor theorem. For any polynomial p of x, x minus a is a factor if and only if p of a equals 0. Okay, now that it sounds a little confusing, but let's really understand what we just read right here. It says for any polynomial p of x. So when I say p of x, any polynomial, look right here, this is a polynomial right here, right? Any polynomial, it's x squared minus 1x minus 20. So it says that x minus a is a factor if and only if p of a equals 0. So we already divided and we got a remainder of 0. That means that this really is a factor of this polynomial. So let's reiterate that. X minus 5 is a factor of this quadratic trinomial. So in other words, over here it says x minus a is a factor if and only if p of a equals 0. You might not remember, but p of a means for you to plug in the a value. So if we take a look at this problem, what would the a value be? Remember, it says x minus a, we have x minus 5, so the a value would be 5, okay? So it's saying that if you plug in the a value using synthetic division or even regular substitution, check it out. if I use regular substitution on the x squared minus 1x minus 20, I'm getting that from here. And I substitute the a value, right, which is really negative 5. If I plug that in, let's plug in, actually not negative 5, it's positive 5, because you think opposite of what you see there. So if I plug in a 5, and I plug in a 5, I know that my output is going to be 0, all right? When you plug in the a value, your output's going to equal 0. Check this out. 25 minus 5 minus 20, yeah, it's going to equal 0, okay? So what the factor theorem says is that you could check and see if this is a factor of this by simply plugging in the opposite of what you see here into the function itself, and your answer is 0. It says it will be a factor if and only if p of a equals 0. Now, you don't have to plug in using regular substitution. You could use synthetic substitution, which is something that we already did right here. I mean, what did we actually do here? We plugged in the 5 using synthetic substitution, and we got out 0. So technically, you could take any polynomial and plug in your number using synthetic substitution, and this will be your output. And once again, what the factor theorem says is that if you do plug in the number, you're going to get 0 as an answer if it was a factor. And likewise, you could think if x minus a is a factor of p of x, then p of a equals 0. Okay? So synthetic substitution is way better than regular substitution. Like for example, I mean, any function, like this one right here. Let's say I told you to plug in any number. Let's say I told you to plug in 2, for example, all right? Would it be wise to use parentheses and actually plug in a 2? No. The easier thing to do would be to use synthetic substitution, put the 2 in the box, put the coefficients of each. There's a 1, a minus 4, a minus 7, and a 10, and do synthetic substitution. Bring down the 1. 2 times 1 is 2. And then you bring down the minus 4 and 2 is minus 2 when you combine them. And then 2 times negative 2 is negative 4. And negative 7 and negative 4 is negative 11. And then 2 times negative 11 is negative 22. And at the very end, it's not synthetic division, so it's not the remainder, but it is actually the output. So the answer is negative 12. So if I told you, hey, go and plug in a 2 right here on the x, a 2 right there on that x, a 2 right there, and work out all that math, you're going to get the answer negative 12. So I hope we're starting to understand that we could use synthetic substitution instead of regular substitution. You just plug in the number you want into synthetic substitution. Let's go to today's notes, or actually today's practice. So right here it says, is x minus 5 a factor of this polynomial? Okay, is x minus 5 a factor of this polynomial? Well, if we go back to the notes, it says, for any polynomial p of x, x minus a is a factor if and only if, when you plug it in, you get 0 as a remainder, right? And that makes total sense, because if you remember over here, if you're able to divide this by this, you should get 0 as a remainder. So that's where it comes from. Let's go back over here. I'm going to use synthetic substitution. So I'm going to plug in a 5 in the box, okay? And I'm going to do the coefficients, which is 1, negative 4, negative 7, and 10. Let me zoom in even further to get this going here. So when I bring down the 1 and I multiply 5 times 1, I get 5, and then negative 4 plus 5 is 1, and then 5 times 1 is 5, and then negative 5 or negative 7 plus 5 is negative 2, and 5 times negative 2 is negative 10, and yes, the remainder is 0. So what do we know? That this really is a factor of this, right? It's a fact. We know that it works because the remainder is 0. All right? So it's kind of like saying, this. Like, let's say we had a 20 divided by 4. What's your answer? It's 5. Is there a remainder? No. When you subtract, it's 0. Yeah. So 4 is a multiple of 20. In other words, you could factor 20 to 4 times 5 because the remainder is 0. So when they ask you, is this a factor of this? Well, just take the opposite of that, use synthetic substitution, and see if your remainder is 0. And if it is 0, then you know it is a factor, right? How about number 2? Is x minus 2 a factor of that one? Well, let's try it out. That means that inside the box, we're going to have a positive 2, and then we have a 1, a negative 4, a negative 7, and a positive 10. And let's work out synthetic substitution. Bring down the 1. 2 times 1 is 2. Negative 4 plus 2. Negative 4 plus 2 going down is negative 2. And we have 2 times negative 2. That's negative 4. And negative 7 and negative 4 coming down is negative 11. And 2 times negative 11 is negative 22. And of course, the remainder is not 0. So the question is it a factor? Is this a factor of this? Absolutely not, because we don't get 0. And I put 0 there. I probably shouldn't have put 0 there. What do I really have as a remainder? I have a negative 12 as a remainder. So we know for a fact it doesn't work. It's not factorable. It's not that it's not factorable. This is not a factor of this. If you were to take this and divide it by this, you're going to get a remainder. And the way we find out whether it's factorable or not, or whether it is a factor or not, is if the remainder is 0. And in this case, it is not 0. This next one's a little bit more interesting. It's kind of crooked, huh? I wrote it crooked on the board. So let me straighten it out here. So 3, we have, is a binomial x plus 1 a factor of this? I don't know. Let's check it out. How could you verify the statement? Explain. Well, of course, we've been doing this. You're going to use synthetic substitution. Plug in a negative 1. You're going to have the coefficients 1, 4, negative 25, negative 28. Okay? So the 1 comes down. We have negative 1 times 1. That's negative 1. We have a 3 when you bring it down. Negative 1 times 3 is negative 3. We have a negative 28. And we have a negative 1 times a negative 28. That's a positive 28. So what do we know? The remainder is 0. So what could we say? That yes, absolutely, this is definitely a factor of this. Explain. Why? Because when I plug in negative 1, I get 0 as a remainder. In other words, when I divide this whole thing by this, I don't get a remainder. It's 0, which means it is divisible. It works out. Let's move on to 3b. It says factor the above cubic polynomial. Well, if we know that this is a factor of that, then I know for a fact that what we see down here is the remaining polynomial. So check this out. Let me show you what we have so far. We have an x plus 1 because we know that that's a factor. What else do we have? We have whatever's left right here. This is supposed to be your remainder, which there isn't any. This is your constant. This is your x value. This is your x squared. So you really have an x squared plus 3x minus 28. And now the only other thing you could do is realize that you could continue factoring the x squared plus 3x minus 28. What does it become? It becomes x minus 4, x plus 7. What times what is negative 28? That if you add together is 3. There you go. Don't forget to bring down the x plus 1. And ladies and gentlemen, this is your completely factored form of the above cubic polynomial. I hope you got it. See you in class.